Hello, everyone. It's a good morning. Dear author and invited guest, this is a technical session 2D. Myself, Richa, and this session will be moderated by me. On the behalf of the Global Knowledge Research Foundation, it's my great pleasure to welcome you to the International Conference on Information Communication Technology for Intelligence System, Ahmedabad, India. The seventh edition of this conference being organized in a hybrid mode. The physical event was held in Ahmedabad on 27th of April, and the virtual event is being held through today, that is 28th of April. I hope this session was informative and knowledgeable through the day. In this session, we have a 10 papers. Each paper will be allocated 10 minutes for presentation, which will be given 8 minutes for presentation and 2 minutes for question answer. After 7 minutes, I will raise a gentle reminder to conclude the presentation. So I have another request to all the participants. Please kindly stay connected till the closing remarks. If you have any query and any update, write it to me in a chat box. Just before we get started, I would like to introduce to our chair of this session, Professor Vijita Kumawat. Dr. Vijita Kumawat, she's a deputy HOD and associate professor in a department of CSE at Jaipur Engineering College and Research Center in Jaipur, India. She has a 17 years of teaching experience as a head of department and associate professor. She has published a book of 3 edition of Computer Network of Rajasthan Technical University. She has two Indian patents. She has expertise in ad hoc network, wireless sensor networks, and Internet of Things. She has 45 international and national publication. Welcome to you, ma'am. Now we will start. Thank you, ma'am. Now we will start with the paper's presenter to present her paper on a review on digital image watermarking techniques using neural networks.
Thank you, ma'am.
Dear presenter, you may please start your presentation.
Yes, ma'am. Yeah. Very good morning to session chair, moderator, and attendees. Myself, Mangla Gauri Gorbal, is going to give presentation on my paper, a review on digital image watermarking techniques using neural networks. This is the flow of my presentation. Watermarking a multimedia security. As we all know, nowadays, image processing and the internet have made it easier to duplicate, modify, reproduce, and distribute digital images at low cost and with approximately immediate delivery without any degradation of quality. Also, network and communication technology has been developing and progressing so quickly that it threatens the privacy and security of data. Therefore, content authentication, copyright protection, and protection against duplication play an essential role in facing the challenges of the existing and upcoming threats in maintaining digital information. Data hiding methods like watermarking has become a key player in solving this biggest challenge of multimedia world. A watermark is a form, image, or a text that is impressed onto the paper, which provides evidence of its authenticity. Digital watermarking is an extension of watermarking concept in the digital world. So digital image watermarking is the digital watermarking of an image. Digital image watermarking basically consists of two processes. One is the embedding process, the other one is the extraction process. In the embedding process, the watermark data is embedded into the digital host image, and later in the extraction process, watermarking data is extracted from the watermarked image to authenticate the ownership of the image. Coming to the classification of image watermarking techniques, the digital image watermarking techniques can be classified based on the type of working domain, type of documents, nature of the algorithm used, human perceptibility, and type of application. However, Working domain based methods are very popular and prevalent. So these working domain based techniques are basically classified into spatial domain techniques and transform or frequency domain technique. The spatial domain techniques have the benefit of low cost but less robust than transform domain based watermarking. The transform domain techniques are very prevalent as they exhibit superior performance in terms of imperceptibility and robustness. Coming to what are the characteristics of digital watermarking, they are imperceptibility, robustness, security, data payload, and computational complexity. However, imperceptibility, robustness, and security are the most important performance parameters of neural network-based watermarking schemes. So most of the papers reviewed have stressed on these parameters. So looking at to what is imperceptibility, it is the most significant requirement and it refers to the perceptual similarity between the original image before watermarking process and the watermarked image. The robustness is the ability of detecting the watermark after some signal modification, such as spatial filtering, scanning, or due to some intentional attacks like cryptographic and protocol attacks. Then coming to the security, security is the ability to resist against intentional attacks. These attacks intend to change the purpose of embedding the watermark. Coming to the performance metrics, the performance matrix of a watermarked image quality is measured by evaluating some performance metrics or benchmark tools. Here are the most important one. First one is the PSNR, that is the peak signal to noise ratio, which mainly focuses on visual similarity between the original and the watermarked image. Higher the value of PSNR, better is a system and more is the efficiency of the system. Then comes the structural similarity index, which evaluates structural similarity between the original and the watermarked image. Then the normalized coefficient, which helps in evaluating the robustness of the technique in the presence of attacks. Next is the NPCR and UACI. NPCR accounts for the number of pixel change rate, whereas UAC measures difference of average change in the intensity between the plain and the encrypted images. Then last one is the normalized mean square average error, which calculates the average squared intensity difference between the reference watermark and the extracted watermark. However, the PSNR and the normalized coefficient are the most frequently used quality metrics for watermarked images, where the PSNR determines the intensity of strength and weakness of watermarking techniques, while the NC validates the strength of the used algorithm applied to a watermarked image after attacks. Recently, the watermarking approaches used soft computing techniques to improve the performance of their systems. So those are neural network based, fuzzy logic based, genetic algorithm based, support vector machine based, PCA based, and meta heuristic based. However, I will be concentrating on techniques using neural networks. A neural network is an information processing system which models some of the functionalities of the human nervous systems. Uh, Neural network basically consists of highly interconnected processing elements called neurons, and each neuron is connected to the other neuron by a connected link which have an associated weights which contain information being used by the neural net to solve a particular problem. Coming to the different types of neural networks used in watermarking, they might be feed forward neural network or recurrent neural network. In feed forward, the information moves only in the forward direction, and in the recurrent neural network, the output can be directed back to the nodes in a preceding layer. The greatest forte of a neural network is its learning and adaptation ability. That is, the neural networks are characterized by their ability to learn, recall, and generalize similar to that of a human brain. This makes them very efficient and powerful. In watermarking, the capabilities of conventional methods are enhanced by neural networks by memorizing the actual relation between the watermarked host image and the watermarked data. Coming to my literature review, uh, the first 7 papers which I have reviewed are based on feed forward networks like backpropagation neural network, in different transform domains. These methods provide good performance in terms of robustness and imperceptibility. The normalized coefficient in these cases are found to be greater than or equal to 0.96 for most of the common attacks. In terms of imperceptibility, these methods achieve average PSNR of 43.7 decibels, which is a good quality indicator. To enhance security, few approaches have adopted encryption of the watermarked image before transmission. The approach using PNN provides excellent imperceptibility and robustness with PSNR of 68.27 decibels and normalized coefficient of 0.97. In the paper, which uses generalized regression neural network, adaptive embedding strength selection is employed, which enhances the visual quality of the approved technique. Coming to the applications of the image digital techniques, major applications, that is major conventional applications are copyright protection, content authentication, owner identification, broadcast monitoring, and copy control. However, recently, the digital image watermarking has found application in various fields, which are tabled in this particular slide. That is e-governance, relational databases, 5G technology, cyber systems, smart healthcare, 3D images, IP protection, digital forensics, military applications, remote education, digital file archiving, IoT, hardware safety, medical field, smart city application, protection of cloud storage, e-voting, secure data on social media. Coming to the conclusion, different models of neural networks have their advantages and disadvantages. Several papers are using neural networks models like probabilistic neural network, conventional neural network, backpropagation neural network, generalized regression neural network, and so on. However, the backpropagation neural network is found to be the most frequently used neural network model for the image watermarking process because of its competency in good nonlinear approximation. The robustness of these schemes are assessed by using various attacks like filtering, JPEG compression, rotation, cropping, and noise addition. Combining encryption and watermarking is an effective way to increase watermarking security. However, this increases computational complexity. The computational complexity can be minimized by choosing and exploring the different combinations of frequency domain transforms, neural network models, encryption techniques, and error coding code techniques. I would like to conclude by saying that there is large scope for enhancing the existing techniques and making them more reliable, secure, and robust. Following are the references which I have referred for my paper. Thank you.
Okay. Am I audible, Mangala Gauriji?
Yes, ma'am. Yes, ma'am. Very much.
Yeah. Yes, ma'am. Your presentation is very good.
Yes. Thank you, ma'am.
But I observed that it is, yes. I think it is your review paper.
Yes, ma'am.
And you have covered almost all the areas like characteristic, performance metrics, security issues, approaches, application, etc.
Yes,
so it is all good for review paper.
Yes,
so
ma'am.
It is good, and your presentation is also good.
Thank you so much, ma'am. It means a lot to me, ma'am. Thank you.
Yeah. In your literature review,
yes,
you have mentioned, and I think you have studied about PSNR.
Yes, ma'am.
Yeah. Can you explain what is how it works, PSNR?
Shall I go back to that?
In your literature review?
Yes.
One of the paper where the units, the values you have compared in terms of PSNR. Yeah, higher value indicated.
Yes,
good
yes. Yes, ma'am. Normally, the range which usually they recommend is like if your PSNR is greater than or equal to 48 decibels, the
Yeah.
system or the approach is considered to be excellent. And if it is lying between somewhere around 35 to 48, the system is considered to be good. And if it is between 29 to 35, this is considered to be acceptable quality. However, if it is very less than 25, then the image becomes perceptible.
Yeah.
So this is how normally the PSNR is considered for evaluating the quality of watermarked image.
This time you have presented review paper, ma'am, but
Yes.
next time try to take some comparison values or result oriented paper.
Definitely.
Try to work on it.
Yes,
Right, ma'am?
definitely. Definitely, madam. Yeah, I
Okay,
will
good,
note.
good, ma'am. Yeah.
Thank you, ma'am. Thank you so much. Yeah.
Now I would like to call our next presenter. Sarvesh, to present his paper on analysis of magnitude of threats of V2X authentication schemes under quantum powered advisory.
Is the screen visible?
Yes, sir.
Uh, Good morning, everyone. I'm Sarvesh Savan. I'm from NITK. This is my paper on analysis of magnitude of threats for V2X authentication schemes under quantum power adversary. So these are the topics which I'll be covering. One is introduction, motivation, problem statement objectives, literature review, challenges in developing these schemes on post-quantum cryptography, conclusion, future work. What are the references? So introduction. So IOB, the evolved transportation, like we can say, there was a time when we would travel in buses and we would stay in the for long queue for the bus and all. But now almost everybody has vehicles, and these vehicles are capable of giving us the GPS, the traffic information, and also provide us entertainment in the vehicle, etc. So we see there's a lot of evolved transportation now. So all of this is possible because one of the things that is something called as Internet of Vehicles. That is, a network of vehicles that interconnects with other vehicles and surrounding infrastructures. So because of this, when IOV is completely deployed, we will get a real-time sense of the surroundings and what is happening in the environment, which is making our travel more safe, reliable, robust, and smart. Like for example, when we order some product on Amazon or Flipkart, what happens is we can actually track it when it's coming, like when it's delivering, where it is reached. So we see it's a direct implementation of safe and reliable IOV in some form. But like every other technology, IOV also comes with its challenges. Now, in order to understand these challenges, let us first understand the architecture of the IOV. So here we can see there is one process authority. There's RSU, which is the roadside unit, which will be installed at the side of the road. And there's a vehicle in the middle. So this vehicle has the sensors, has the OBU. OBU is called the onboard units. And there's a lot of communication happening around. So you can see V2R, that is vehicle to the roadside unit communication. V2I, that is vehicle to infrastructure communication. V2V, that is vehicle to other vehicle communication. And of course, there's vehicle to the customer authority communication. So this is the basic architecture of an IoT. So when we talk about challenges, the biggest challenge here is that time-bound response. Since these vehicles are moving very fast and data communication should happen as fast as possible, the expected time that we get, I mean, the average time between two vehicle communication for message communication is around 300 milliseconds, which is very less. Second is dynamism in network topology. Since vehicles are moving fast and they go from one place to other place in a few minutes, there's a lot of reheating and network reconfiguration happening. So this is the second problem which comes in IoV. Third is computation and storage. These IoVs, they are devices which are locally installed on these vehicles, And this devices, they have very less computational power and storage capacity. The fourth and the major one is veracity and authenticity of message and messenger. If two makers are communicating, it is very important to know that the message who is sending is the one sending message is the authentic person, and he is saying taking the credibility of the message that he is sending. This is a very important point with respect to security in IoT. In my paper, I've considered basic five attacks, and based on that, I've done some security analysis. So, first one is impersonation attack, in which the attacker behaves as the legitimate member in the network and provides some flows some message in the network. Second is ID disclosure attack, in which the attacker is able to retrieve the details of the ID of other vehicles. Third is the modification attack, in which the attacker will introduce some doctored messages, like he may introduce that there is a road accident ahead when there is no accident. So these are modification attack example. Next is replay attack. That is some attack which is some message which is done before is introduced now in the network. And fourth is location tracking. Like suppose some message the attacker has somehow able to retrieve, he can understand that okay, this message has come from this particular location, so this vehicle is residing in this location. So these are the five attacks that I have considered for my analysis. Now to restrict all these adversaries, right? In IoV, like I said, it is a very dynamic network and time bound and cost very uh, I mean it's having very limited resources with it. The methods that are developed to provide a strong security were mostly lightweight, and these sector methods are categorized in one symmetric crypto systems, in which basically it means that only one key is used to encrypt and decrypt the message. Second is asymmetric crypto systems, in which there is a public private architecture framework in which the public key is used to encrypt the message and the private key of the receiver is used to decrypt the message. And third is hashing function, that is based on some function. The message is encrypted in such a way that nobody can read or make sense of what is coming out of the message. So these three major categories were considered to develop various schemes to provide security for IoT. Now the problem comes with quantum systems. Now it is said that by 2030, quantum systems will be available in the market. So what happens is quantum systems, they use something called as qubits, and qubits also exhibit in the state of 0 and 1, which is similar to classical because classical also exhibits in state 0 and 1. But the difference is in the computation. That is, the quantum systems can exhibit in 0, 1, and 0, 1. So 0, 1 is nothing but a superposition of 0 and 1 bits together, because of which the range of computational power is immense to the quantum systems. And this is what is the biggest challenge right now. So classical computer at a given time will be in either 0 or 1 state. Now, Shaw's and Grover's algorithm have proven to break asymmetric key cryptography. Recently, Google have said that they are able to crack RSA algorithm in just a few seconds. So, in asymmetric key, I mean, the encryption system that we have now are at great risk because of quantum systems. And imagine this quantum systems are with the adversary, there is complete havoc happening. But one thing was observed, that was symmetric key and hashing functions with bits more than 256 are said to be quantum safe. But the catch is that all of this is done through physical theoretical proofs. And when the systems are practically deployed, we never know what is going to happen because theory and practicals are two different scenarios. So just depending on symmetric key and hashing functions was something the researchers could not be satisfied with. So they started working on something called as post-quantum cryptography, which is also termed as quantum safe. So what is quantum safe or this post-quantum cryptography? It's nothing but the classical system that we have. These systems will they will develop such problems which are NP hard.
Dear presenter,
Can
you have last 1 minute. Please conclude your presentation.
yeah, I just give it to myself. I finish it.
Mm.
So yeah, so it is something that will have yeah. So post-quantum cryptography is nothing but this is um, yeah. So it is can be this problem can be solved by not solved. This is hard even for the quantum system to solve. So such areas are called post-quantum cryptography. So it's the motivation that is of course low powered devices, and it should be advantages, and it is because of unsecured, it is advantages to adversaries, and the success rate of adversaries increase exponentially. So in this paper, I have analyzed the system with respect to quantum powered, and also talked about challenges developing quantum systems using post quantum in with respect to quantum powered adversary. So this is the basic review I've done with respect to classical adversaries. This is the review I've done with respect to the quantum
Skip,
adversary.
Sarvesh ji, skip this literature review. Can you come on your direct result page?
Yeah, this is actually what is my analysis, ma'am. The right side you can see, right, 1, 2, 3, 4, 5. This is
Okay.
what is my analysis on that, and this is my analysis on the quantum adversaries for the particular existing problems. So, so challenges developing this post-quantum cryptography schemes is that post-quantum is still a nascent stage, and uh, quantum power systems are their resources is growing exponentially, and PQC is still in nascent stage. And also PQC is they have currently large key size, because of which there is, and as we know, IOB is a time and space network space restricted framework. So it needs to be properly fine-tuned. So conclusion is basically we need to develop schemes that are quantum safe, and are can be used in the IoT communication. So that's it. These are the references.
Okay.
I think.
You have mentioned quantum safe, a term in your paper. What is this quantum
Yes.
safe?
See, ma'am, quantum safe and post-quantum cryptography are same. It is just saying that uh, when these quantum systems are developed, are deployed, right, the classical system that we have currently, so these
Mhm.
systems should be also safe with respect to the quantum adversary. So
The
this
value,
quantum
the value 256 you have mentioned. How you identify this value 256? It is
it
on
is
any result base or how?
it is now the bit size is anyways it's mentioned by the all the hash functions has the like 128 bit 256 bits. It is a known value now. It's not my research work. It's already
Okay.
known. What I have done is I've analyzed the existing schemes with respect to the adversaries, and whether this scheme is uh, standing against or withstanding this attack or not. That is what I have the analysis in my paper. And then second thing I have said that whether this scheme that which I'm saying, like for example, uh, take this scheme, for example, this one,
Hmm. Yeah.
okay, which is saying cross. So that means this scheme is under asymmetric cryptography, and it is strong against classical adversary of. But since it is asymmetric cryptography, it is
Hmm.
not safe under quantum adversary. But classical adversary, it is safe. So
Hmm.
this analysis I have done uh, on the papers just selected.
Okay. Okay, Sarvesh ji.
Yes, ma'am.
Now we can call our next presenter.
Yeah, I just thank you, everyone.
G. Lakshmi to present her paper on comparative analysis of machine learning algorithms on mental health dataset.
Morning, everyone. And the presentation is about the comparative analysis of machine learning algorithms using mental health dataset. Nowadays, maintaining the good health is very important for a person. Due to prolonged working hours and hectic schedules, both IT and non-IT professionals are prone to stress. Even though the companies provide the health incentives, they cannot address this issue properly. So the study compiles the data of both IT and non-IT professionals, and the data is collected from OSMI, Open Source Mental Illness Organization. Coming to the introduction, the employees in the private sector are frequently depressed or they are prone to stress because of long working hours and short time frames. So for the businesses to develop and to improve the potential capacity of the employees, it is better to provide a stress-free environment for the employees and higher productivity. One of the best things for lowering the stress is educating and assisting the peers to deal with the mental health concerns. While selecting the peers are given sufficient training by the experts, and then they educate and assist the peers. The algorithms that are used in this research are decision tree, naive-Bayes classifier, and logistic regression. Coming to decision tree, it is one of the supervised by the name, it suggests that it's a tree-like model and it is used for hierarchical classifications. It is used to model several if-else statements. Decision tree mainly consists of two nodes, decision node and leaf node, where decision nodes are used to make any decisions and they have multiple branches, whereas leaf nodes suggest the outputs of the decision nodes and they are the endpoint of the trees. Decision trees are used because they are easy to interpret and they mimic the human actions while making any decisions. Coming to the naive-Bayes classifier, this classification is based on the probability. It is mainly used in spam filtering, sentimental analysis, and article grouping. And it is based on Bayes theorem. The formula is given below and the terms are explained. Here, the posterior probability means the probability of the hypothesis, updated probability of the hypothesis after gaining the data set. Prior probability of the evidence.
Excuse me, G. Lakshmi, your just first slide is visible. Your first slide is visible only. Yeah, now it's okay. Yeah, continue please.
Okay, prior probability means the probability of the hypothesis before gaining the data set or knowing the information. It means it is based on the past experiences. Naive-Bayes classifier is used because it for training the data set. It requires less amount of data for training. Logistic regression. It is also one of the example of supervised learning. It is used for both classification and regression. It is generally used mainly for the binary classifications. It is also suitable for categorical values to predict the categorical values. Applications, it is mostly used in healthcare industries, financial industries, and marketing. The paper follows this methodology. First, I have collected the data from open source mental illness, and it is pre-processed so that the collected data set contains many attributes. Out of them, only the selected attributes are required for the research. So it undergoes pre-processing and splitting of the data set and then training the model by implementing the algorithms like decision tree, naive-Bayes, and logistic regression, and the results are compared. The data set from open source mental illness is collected. It's a non-profit organization which is used, which brings the consciousness of mental health among the people. Data cleaning. Initial data set that I have collected from the OSMI consists of 27 attributes, out of which only 20 attributes are considered for my research. performance evolution. The parameters which are used to evaluate the performance of the algorithms used are precision, recall, and F1 score. Precision is nothing but the percentage of outcomes that are correctly predicted by the model. Recall gives the proportion of positive outcomes that are correctly predicted, and F1 score gives the accuracy. And this is the confusion matrix, and based on confusion matrix, we have compared the results. And this is the graphical representation of the results obtained by the outcomes. By seeing the graph, it is clear that decision tree has more precision, recall, and F1 score compared to the remaining algorithms. Conclusion is that based on the comparison of all the three algorithms, decision tree obtained better results in terms of accuracy rather than the Bayes classifier and logistic regression model. As there is more data in the healthcare industry, if the prediction models are correctly trained and fed into the intelligence system, then they can reduce the human error and reduce the diagnostic times. In future, we will be using some deep learning techniques to evaluate mental stress, to predict the anxiety, overthinking, and other mental issues. And there is references. And these are the references I have chosen.
Okay. Lakshmi, I have just only two questions.
Yes,
Hello.
ma'am.
Yeah, I
Yes,
have
ma'am.
two questions. One first is that which tool you have used for the comparison of these three algorithms?
Which tool, ma'am? Implementation, ma'am.
Yes. Yes.
Python, ma'am. In Python, I have implemented Jupyter notebook.
Jupyter.
Jupyter notebook. Yes, ma'am.
Okay, okay. And I just want to ask that open source, the data set you have used this time, suppose you have a different data set, then FI score will be changed or not?
With the same data set can be used to train the model, ma'am. For different data sets, different
because the value of FI score will be changed according to the data set.
Data set. Yes, ma'am. For this data set, decision tree is better than other algorithms.
Okay, okay. Decision tree is better.
Yes, ma'am.
Okay, okay. Okay, Lakshmi, your presentation is good, and the content or data which you have mentioned in your presentation, it is also very good.
Thank you.
Okay.
Now we can call our next presenter. Prajakta to present her paper on comparative study for a computer version technique for locating instance of objects in images using YOLO versions.
Okay, thank you, ma'am. Hello, everyone. Good morning, the session chair, moderator and attendee. Myself, Prajakta Khaire. I'm going to present here my review paper, Comparative Study of a Computer Vision Technique for Locating Instances of Object in Image Using YOLO Version, a review, under the guidance of Dr. Dilendra Hiran and Dr. Ramesh Shirke, under ICTIS 2023, Ahmedabad. The flow of my presentation is on introduction, working of YOLO algorithm, advantages, comparative study and literature review of all the versions from V1 to V8, conclusion, future scope, and references. So today, much research focus on object detection. The process of searching and identifying things in still or moving picture is tedious. Computer vision methods for object detection provides the basis of artificial intelligence methods used to address these issues. There are a wide variety of methods for finding and naming items in the still photograph and moving videos. Some of the applications are investigation, autonomous vehicles, and robotics. Based on how many times the same input picture has been processed by the network, object detectors may be classified as a two-stage object detector and single-stage object detector. The single-stage object detector means the entire image can be identified, analyzed, and located in a single pass, whereas this doesn't happen in a two-stage object detector. I am concentrating on the single stage object detector. Under single stage object detector, YOLO algorithm I have explained. The YOLO is an instant detector that performs visual analysis using a fully convolutional neural network. Mostly, single shot detector is the best to detect and analyze the objects in image. So let us focus on the YOLO algorithm. The YOLO algorithm was developed by the Joseph Redmond in 2015. The YOLO model is mainly used for object detection due to its speed, good generalization, open source, and detection accuracy. YOLO uses a fully connected neural network that predicts both bounding boxes and classes simultaneously. The previous generation object detection algorithm used a technique that stayed classified to carry out the detection, but YOLO avoids it. YOLO is the best solution for identifying and locating the images. In the YOLO, each picture is partitioned to carry out the detection into S by S grids. And from these grids, prediction and n bounding boxes with their confidence levels are derived. So let us have some focused on convolutional neural network first. YOLO uses CNN to recognize and identify items. A CNN is a kind of deep learning algorithm that can take an input image. After that, it gives different parts of that particular image some weightage and bias it that it learns, and then classify the different parts of the image accordingly. CNN requires far less preparation than other classification methods. Unlike the traditional approaches in which filters must be created by hand, CNN may learn their specific properties with enough practices. So let us have a look on working of the YOLO algorithm. The YOLO algorithm takes an input picture and uses a shallow deep CNN to find items within it. The architecture of CNN is basically divided into three parts: input, feature learning, and classification. The CNN is comprised of 24 convolutional layers and 2 fully connected layers. Each picture is broken down into n by s squares by the technique, and then inside each of those squares, some squares are defined as a bounding boxes along with confidence estimates. If the geographic coordinates of an object's center are found inside a certain grid cell, then that cell is the one that must be used to pinpoint the object's location. Each cell in the grid estimates a box with a certain confidence level inside of it. So we can say that the dimension of S by n boxes are approximated and confidence value of a low boxes are ignored. So in this slide, I have mentioned some advantages of one version over another from YOLO V1 to V8. The table here shows or explains a comparative study of advantages of YOLO version V1 to V8, which includes architecture, anchor boxes used, frame size for image processing, and its features. YOLO V1, it uses darknet and process image at 45 frames per second, and it is easy to detect, localize the objects using YOLO V1 algorithm. YOLO algorithm has a good accuracy and speed. YOLO V2, it uses a different CNN backbone called Darknet 19, a variant of VGG-net architecture with simple propagating network and pooling layers. It uses 5 anchor boxes and k-means clustering and processing image at 42 frames per second. YOLO V3 uses new CNN architecture called Darknet 53, and it also uses k-means clustering and it processes image at 95 frames per second. YOLO V4, it consists of a backbone consists of backbone CSV darknet 53, and it also uses k-means clustering and process image at 65 frames per second. YOLO V4 is optimal speed and accuracy object detection. YOLO V5, it employs more sophisticated architecture called as efficient date, and YOLO V5 is very good prediction alignment and prediction refinement for object detection. YOLO V6, it uses the efficient net L2 architecture, dense anchor boxes, and it uses COCO dataset and process image at 1234 frames per second with fewer parameters and improved computing efficiency. YOLO V7 uses YOLO network architecture, and it uses 9 anchor boxes using k-means clustering, and it processes image at 155 frames per second. YOLO V8, actually it is under establishment, and it uses new technology, that is ultralytics technology, and it is an anchor free model. The ultralytics used in YOLO V8 are supposed to bring forth several improvements and additional features over the previous versions. So let us move to the comparative study and literature review of a YOLO version V1 to V8. This table will explain the comparative study and literature review of all the versions, which includes the conclusion on the referenced research paper, improvements from version to version, and the result. The first paper, in the first paper, author discussed the comparative study of the other object detectors with YOLO and experimental work of the YOLO algorithm. In the second paper, the author introduced version V2, that is YOLO V2, and it introduced two real-time detection method called YOLO V2 and YOLO 9000 when compared to other object detection methods. In the third paper or in the third article, the author discussed the overview of YOLO V3 and also discussed its working process and stated that it improves detection of a smaller object. In the fourth, that is YOLO V4 version, in this paper, the author stated that or discussed the practical testing of feature combination of large data sets and theoretical rationale of the outcome. In the fifth version, author especially said that it is suitable for object detection in the situation taken by drone. The author discussed and adds various sophisticated approaches such as transformer encoder block. In the sixth paper or YOLO V6 version, in this article, the author discussed the YOLO V6 algorithm, how it works, and explain experimentally the architecture of YOLO V6. In the seventh paper, that is a version 7, author discussed the YOLO V7 algorithm, how it works, and he also explained experimentally the architecture of YOLO V7. Author concluded that the version V7 is better because of its fast interference speed and layer aggregation. And YOLO last paper, that is a YOLO V8, it does not have the published paper yet, and it states that it will use newest SOTA version of YOLO, and it has YOLO V8 architecture, strong accuracy, and COCO dataset. So from all of this explanation, I would like to conclude that we use so many techniques to identify and locate objects in the image and videos, but YOLO is the best solution for them. The YOLO algorithm performs generalized representation of objects more efficiently without loss of accuracy than other object detection models. We also discussed comparative study of YOLO version using parameters. The purpose of this article is to offer context for target image reality and feature extraction. And I also discussed advantages of one version over another one from V1 to V8. So I can say that in future work, we will use YOLO to detect object for higher accuracy rate, and I'll try to improve speed, generalization rate, and detection accuracy. So these all are my reference papers and sites. Thank you.
Okay, Prajakta, your presentation is good. Can you tell me about, can you tell me some applications or any application where this YOLO technology is already uses for object detection?
Yes, ma'am. It is used for investigation or autonomous vehicle detection or robotics, or we can say military application. Many applications are there for this.
Okay, and according to your paper presentation, YOLO 7 version is better.
Yes, ma'am. Till now, YOLO 7 version, total 7 versions are in use. But among that, YOLO V7 is more powerful because of its accuracy and generalizations.
Okay, take care. Okay, please.
Thank you, ma'am. Thank you very much.
Now we can call our next presenter. Abasti, to present her paper on curbing anomalous transaction using sensitive learning.
Is my screen visible?
Yes, it is visible.
So hello everyone. So my paper is curbing anomalous transaction using cost-sensitive learning. So this is my overview. So we know that the internet and digitalization improved our life for better, and it kind of shifted our consumption behavior. It made sorry, it made transaction more transparent and easier. So we know that one such popular method of payment is credit card, and it allows us to make quick transactions, smooth payments, etc. So, but in spite of all these, credit card is also a major target for scammers, and the anonymity that the internet feeds give these perpetrators a false sense of security. So there are also like several reports claiming that there's a significant surge in malicious activities, and it will reach like $43 billion in 5 years. So we know that like scammers are there and fraudulent activities are happening. So in order to detect this, there are certain traditional algorithms and techniques. But the problem is that this credit card data sets, or the data set that we acquire, would be highly imbalanced. Imbalanced as in the amount of, for example, the amount of genuine transaction would be higher than the amount of ingenuine transaction, which causes a imbalance in the data set. So what does this traditional algorithm does is that it tries to even out the data set, ignoring the negative classes or the minority classes, and make prediction based on that, which will cause a poor generalization or a classification error, which also leads to misclassification of cost. So my objective is to minimize the misclassification of cost. So I already mentioned that there is this class imbalance problem. So there are several techniques to overcome this class imbalance problem, such as data level approaches and algorithm level approaches and ensemble level approaches. Let us look into data level approaches. So data level approaches basically consist of oversampling and undersampling. Oversampling simply means we are adding certain data into the minority classes. We are adding certain points to the minority classes so that it balances with the majority classes. So undersampling means it removes certain instances from the majority classes. So this oversampling and undersampling is again divided, or it has certain techniques such as SMOT, which is synthetic minority oversampling technique, borderline SMOT, and ADASIN, which is adaptive synthetic sampling, whereas undersampling contains random undersampling and Tomic links. Synthetic minority oversampling technique means that it uses certain synthetic data points. It adds certain synthetic data points into the minority classes using augmentation. Augmentation just simply means that the generated data points will be slightly different from the minority classes, and it will be added or populated into the minority classes. So what happens here is that finally, when classification is being done, the initial the synthetic points or the final class would be maybe would be different from the initial data set. Also, such kind of adding data points works better with the small data set. While credit card being a very large data set, it's not ideal to use this method. So the next method is borderline smart. Borderline smart simply what happens in borderline smart is that it considers two points. One would be border points and border points, and the other would be noise points. Border points simply means that those are the points which are closer to majority classes, which will have at least one neighbor as a majority class, and noise points are which are points which are far away from the majority classes in minority classes. So what it does is that it removes the noise points and learn the decision according to the border points. So the what happens here is that here we are using a very restricted learning. We are not considering the whole points and certain things. So the next is ADASIM. It basically like samples the minority classes or the border points so that we can reduce the learning bias which happened in the borderline mode. So coming back to the undersampling techniques, which is random undersampling and atomic links. Random undersampling, as the name suggests, it's randomly removes the samples or instances from the majority classes. So what happens here is that while we randomly remove such informations or classes, there is chances that we lose like certain valuable informations or very significant informations. And the next one is atomic links. So we already discussed that smooth kind of populate synthetic data into the minority classes, and it also causes overlap. So what does this atomic link does is that it pairs the minority data points and majority data points and make a pair, and it will look like a link, and remove that from the data set so that a boundary will be formed and the learning can be done in that boundary position. Since misclassification of this border points are misclassification of the border points are high, the chances are high there. So this is, so we already looked at smooth the undersampling and oversampling techniques kind of loses informations, or it generates unnecessary data, so or overlaps. In order to like curb this, or in order to mitigate this, another technique is that hybrid sampling, where it is simply the combination of an oversampling and undersampling technique, where smooth and atomic is used. Smooth is used to generate synthetic data points, and the overlap data set will be moved using atomic. So that is what smooth and atomic is. So we discussed that the data level algorithms like sampling and resampling are certainly helpful in balancing the data set. Similar to this, certain optimization algorithms can also be used for balancing classes, such as flower pollination algorithm, particle swarm optimization algorithm, and genetic algorithm. So FPA is simply a meta-heuristic optimization algorithm, which mainly works by like maintaining a population of flower. We'll select a random flower, we'll check for the initiate a random population, and we'll check for the fitness function, say the distance between or the strength of the pollinator agent, and we'll search for the best solution. And unless a stopping criterion is met, it will run. Unless and until a stopping criterion is met, such as number of generation, etc. So what happens here is that FPA generally causes local optima, means it will always be stuck in a local solution. The search space won't be large while comparing with the other solution. So PSO is what particle swarm optimization. It's a population algorithm inspired by swarm, such as like birds flocking, etc. So it also what happens here is that it initializes random particles and like check with the position and velocity of the particle, evaluate the fitness function based on these parameters, and update the particle according to the best solution that gets, and then unless a stopping criterion is met. So here also the same problem as the FPA occurs, such as local optima. it will get stuck in the local optima. So moving on to the next algorithm, which is genetic algorithm. So what happens here is that it is also an evolutionary algorithm, which here what happens is that the population is initialized, and we are evaluating the parents according to their fitness function, which can be the quality of their chromosomes, etc. And then the selection is done, parents are selected, and certain operations are done on this parent, such as crossover and mutation, and to get a best solution. So unlike FP and PSO, GA does provide a large search space, where we can search for a global best solution, and it also get us the optimal solution. So we have looked at the sampling, resampling, hybrid method, and naturally inspired.
Dear presenter, you have last 1 minute.
Algorithm. So we are it only manages to balance the imbalanced data. It ignores the cost of misclassification. Means say if I am or if a person is unhealthy and I am classifying him as a healthy person, which can cause a error, or which can cause a misclassification of cost. That is what it is simply meant by. I'll switch into the proposed system. So the proposed system basically contains 4 modules: feature selection, feature optimization, cost sensitivity, and classification. Feature selection, here we are doing it with correlated coefficient, which basically means that we are selecting features on the base of, we are giving a target features and selecting the other features based on the correlation coefficient. We're setting a threshold here. According to that, obtaining the highly correlated features, and then the selected features are given for feature optimization using GA and selection, crossover, mutation. All those processes are done, and the optimized best solution is taken and applied cost sensitive, and then applied to the classifier, which is a cost sensitive classifier, that is like GBM. The cost metrics will be defined, where like first row will represent the cost of predicting the negative class, and second will be the cost of predicting the negative positive classes. Then this data are split for training, like in ratio of 80 to 30, then convert the target material variables are converted into binary, and then
Okay, Avasti.
So
I have only 2 questions. Tell me the difference between oversampling and undersampling.
Oversampling means we are adding data to the minority samples, and while undersampling means we are removing the data points from the majority classes, so that it evens out to the minority class, and the data set is balanced.
Okay, and you have compared these 3 algorithms: FPA, PSO, and GA.
Yes.
And which one is better?
It is found that for large search spaces, for finding a global best solution, GA is more suitable, while both PSO and FP manages to balance the data set. It gets stuck in the local solution, it gets stuck with the local best solution.
That means GA is better.
Yes.
Okay. Okay, Avasti, your presentation is good.
Thank you.
Now we can call our next presenter, Bhavna, to present her paper on design of sustainable water resource management system for agriculture using IoT.
Good morning, ma'am. Is my slide visible?
Yeah, visible.
Good morning, everyone. I am Bhavna Rathod, and I'm here to present my paper on design of sustainable water resource management system for agriculture using IoT. The contents are as follows. introduction, IoT in agriculture, literature survey, methodologies, conclusion, and future scope. So as we all know that water is very vital resource for life, and it plays a very crucial role in various human activities like agriculture, industries, and for domestic consumptions. As the population is growing, the water demand is also increasing, which is again coupled with changing climate patterns and degradation of water resources. So this has resulted in water scarcity, which is leading to very severe environmental conditions. So my paper, my motive of doing this paper is to conserve water and use the water efficiently for agriculture sustainably without wasting much. So agriculture is both, it is a cause as well as the victim of water scarcity. And we all know that all over the water, out of the available water on the earth, only 2% is available for consumption as fresh water in the forms of rivers and lakes and underground and rain water. So it's very important to save it. And due to extreme weather conditions, due to heat waves and excessive rainfall, the crop also gets affected. And we we can use the technology to help the farmer to monitor their crop health, soil health, and use their water resources efficiently and sustainably without wasting much, and only supplying the required amount of water. So, so the IoT can be used in agriculture field. It has a very huge potential to revolutionize the agricultural field. IoT actually stands for.
Sorry to interrupt, dear presenter. You are still on your first slide.
Ma'am, I have moved. Okay, wait a second. Again, it's showing first slide only.
Yes.
Okay, I don't know what is the issue. Now?
Yeah.
Yes, it's
Okay.
it's moving.
So I have discussed this slide as introduction, and this one I'm discussing. So I was saying that IoT in agriculture has a very huge potential, and it can revolutionize the agricultural field. The IoT simply stands for a physical devices connected with networks and having sensors, software, and connectivity, which allow them to exchange and collect and analyze the data and exchange for further making future decisions. So characteristics of IoT are connectivity, which stands that IoT devices are connected to internet, and they can communicate with each other and other sensors also. Then next is sensing and actuation. So IoT devices are equipped with sensors and actuators which sense and respond to the environment accordingly. Then we come to data collection and analysis. The IoT devices collect data and analyze them to extract insights and make informed decisions. Then we come to interoperability. IoT devices are designed in such a way that they can communicate and work with other devices and systems. Then automation. IoT devices can perform automatic tasks like we can take for example that IoT device can help turn off and on the water pump when the tank is full, or when it is not full, it can turn on to fill up the tank. So it is an automation example. Then we come to security. So security, it is one of the most important factor in IoT, that we need the devices must be secure to prevent unauthorized access and protect users' privacy. So one example can be taken out from IoT in agriculture, that IoT equipped irrigation system not only preserves the water, but also conserve it and supply the crop right amount of water for high improved crop yields and improved soil fertility. Then then we come to literature
Hello.
survey. Yes.
Hello, Bhavna. Can we
Yes.
move directly on the system which you have designed for suitable water resource management system? Directly move on that slide.
Ma'am, my paper is based upon review papers, so I have not included that thing in my paper. So that's why I have not included it in my
Okay.
presentations.
Okay.
If you want, I can explain it.
Just continue your presentation. Okay.
Okay. So the literature survey of my paper is I have gone through many papers, and most of the papers have used IoT based system for water resource management in agriculture. And these papers, the mentioned papers, focus on smart agriculture irrigation techniques, which will help manage the water. And these IoT based system help reduce the water wastage, increase the water efficiency, and improve the crop yields accordingly. So there are many methodology which can be used for water management apart from IoT based system, which is one is precision irrigation, which uses IoT sensors to measure and analyze soil moisture and supply the amount of water required according to the weather patterns and crop needs. Then we come to drip irrigation. Drip irrigation is very common. It is a very vast water efficient irrigation method which deliver water directly to the root plants without wasting water in the spreaded area. Then water quality monitoring. It stands for the devices are used to monitor the quality of water, which prevent the contamination and make the water useful for irrigation and agricultural purposes. Then water recycling and leakage detection. It stands for water recycling, that when there is over flooding or over extreme rain conditions, the agriculture field is over flooded. Then that water can be collected and used for irrigation afterwards. And leakage detection stands for if there is any leakage in the pipe which supplies water to the field, it can detect that and alert the farmer to check their pipes and in result lead to reduce the water wastage. Then we come to data analytics. It stands for processing and analyzing the IoT data, which identify the trends and patterns required by the trends and pattern on water irrigation, water needs required by the crop. And it helps in agriculture as well as industrial purposes also, that how much water is required for particular industry. So only that much will be given. So before conclusion, I want to discuss my design, which I have thought of making. It is a sustainable water resource management system, which the aim of that design is three things. First is monitor the soil health. Second is monitor the storage level of water tank, with the help of water level sensor, and the other is leakage detection with the help of flow rate sensor. So all these three combined will act as a smart irrigation device, which will help in reducing water demand in agriculture field and improve the soil crop yields and maintain the soil fertility, as soil fertility gets disrupted if there is excess water supplied to the field. So in conclusion, we can say that water management is very crucial, and IoT devices help farmers and monitor and manage their water resources and improve their crop fields. So the data, whatever is generated by the sensors and a system, will be analyzed and optimize the irrigation.
Okay,
future.
Okay,
Ma'am?
Bhavna. Okay, Bhavna, tell me some applications based on which is using IoT in the field of agriculture.
Yes, ma'am. There are many applications like the IoT is not only used for water irrigation, it can also be used for crop monitoring as well. So first application can be irrigation, smart irrigation, that water, how much, you know, that water is very limited. So the farmer can use the IoT devices and monitor their water resources in for example, in Punjab, there are many areas where farmers are uh, deprived of water resources. So they just depend on rain for for meeting their water needs. So they can monitor, they can store their water in a tank, and they can monitor how much water it can be used for different crops required by different types of crops. And second is can be monitor their soil health. There are many IoT devices which monitor soil health. They soil sensors, soil sensors help farmers to maintain, monitor their. Ma'am?
Do you know any name of a sensor which can measure the soil health?
Yes, ma'am. I think, ma'am, what I have used in my design is that soil moisture sensor, which has a module also attached with the sensor, which is embedded in the soil for a particular 1 square kilometer, something like that, 1 meter square. There are small sensors as also, and there are large sensors also for large area. So I have
Okay,
used a
Bhavna.
smaller one. Yes.
Okay, Bhavna. Okay, good.
Yes, ma'am. The next
Next
is.
one. Yeah. Next one.
Now we can call our next presenter. It's Breja Mishra to present her paper on imperial analysis of variable thresholding for autoencoder anomaly detector in ECG.
Good afternoon, ma'am. Good afternoon, everyone. My name is Viraja Misra. I am from Jawaharlal Nehru University, New Delhi. I am an MTech final year student. I have done this paper, empirical analysis of variable thresholding for autoencoder anomaly detector in ECG, under the supervision of my guide, Professor Rajiv Kumar, who is also a co-author of this paper. Let's get into the presentation. Identifying abnormal heart rhythms in ECG signal is crucial for diagnosing different cardiac conditions. These heart rhythms are often recorded using ECG. There may exist some abnormal pattern in the ECG signal. These are called anomalies. In our work, we have taken two widely used datasets. One is MIT-BIH and the other is CTV diagnostic, to show the effectiveness of variable thresholding for an autoencoder-based anomaly detection approach. The autoencoder we have used to calculate the reconstruction error, using which we can set a threshold for the anomaly detection process. And finally, we have evaluated the performance of our methodology using ROC curves. ECG signals are usually used to record the electrical activity occurring inside the heart and is often used to check the irregularities such as any cardiac arrhythmia. And the LSTM-based autoencoder architecture is well suited for capturing those long-term dependencies that are present in the ECG signal. And it is trained to encode and decode the ECG signal. Using the reconstruction error that are generated from the original signal and the reconstructed signal, we can set different thresholds which can be used for the anomaly detection process. There are different thresholding methods. One is random thresholding, which refers to setting an arbitrary threshold on the reconstruction error in a random manner. And the other is distribution-based thresholding, in which we set a threshold based on the distribution of the reconstruction error to identify the anomaly. While doing the literature survey, we have got the following research gaps. Almost all the works have used fixed thresholding method to distinguish between the normal and abnormal signal. But it may not be accurate for all the test cases, as the irregularity may vary from test case to test case. So in order to address these research gaps, we have given following research contributions. We proposed a thresholding method to detect the anomalies present in the ECG signal. First, we have taken some random thresholding method to generate, in which we generate a set of random thresholds and evaluate the performance of our model using those thresholds. Then we proceed with the distribution-based thresholding method, in which we have systematically generated a range of thresholds from which we found the near optimal threshold, using which we can effectively do the anomaly detection process. Then we have assessed the effectiveness of both the methods using ROC curve for both the datasets. This is our methodology, and this is applicable to both the datasets. First, we have taken both the normal and abnormal signal and then fed them into the autoencoder based anomaly detector to generate the reconstruction error for each signal. Then we have calculated the mean absolute error of all the reconstruction errors. Looking at the mean absolute error, we have set threshold in both the methods, in both the random thresholding and distribution based thresholding method. In the random thresholding method, we set some random threshold looking at the reconstruction error only. Then in the distribution based thresholding method, which is our proposed method, in this we have systematically generated a range of thresholds, a range of 100 thresholds, from which we found the near optimal threshold that is acting effectively for anomaly detection process, and that effectiveness we have checked using the ROC curves. These are the results obtained from our experiment. The left side indicates the random thresholding method, and the right side indicates the distribution based thresholding method. And in the middle part also, we have checked the performance of the random thresholding method using other performance matrices such as precision, recall, F1 score, and accuracy. These are the inferences that we have obtained from our experiment. Let's get back to the result. So looking at the result, we can conclude some points. First, we can see that we have taken a same set of random thresholds in the random thresholding method, and in that the same threshold value performs differently for different datasets. For example, we can see the threshold 0.08 perform well for MIT for PTB dataset, but the same threshold value perform poor for the other for MIT BH dataset. And if we look at the ROC curves, we can see that the TPR and FPR value for one threshold significantly are in a significant distance from the TPR and FPR value of the other threshold. So looking at these two analyses, we can say that setting a random threshold may not be accurate for the classification of normal and abnormal signal. And we need a methodology in which we can systematically generate a set of thresholds from which we can get the optimal threshold, which may perform well. So we proposed our methodology by doing the same. And we can see that in our proposed methodology, the area under the curve for the distribution based thresholding is much better than the area under the curve for random thresholding, and from which we can found a near optimal threshold, because the distance between the TPR and FPR values for one threshold is very less from the distance between the TPR and FPR value for the other threshold. So let me conclude my presentation with the following conclusion points. The autoencoder based anomaly detection approach is effectively working for detecting abnormal signals, but the effectiveness of thresholding method may vary depending on the underlying architecture of the dataset. And we have also found that the random thresholding method produces varying results for different thresholds for different datasets, but the distribution based thresholding method produces consistent result across all the datasets, and it is more reliable and effective also, the distribution based thresholding method. Further research can also be conducted on other physiological signals to develop more robust anomaly detection model. And this choosing the variable threshold method can also be done using some AI enabled techniques in the further research. This is all about my presentation. Thank you, ma'am. Thank you, everyone. Any questions?
Yeah. Okay, your presentation is good and results
you,
is very attractive. But
Thank you,
which
ma'am.
tool you have used to compare the results? Which tool you have used?
Ma'am, we have used ROC curves to compare the results. The this is the ROC, the left side indicates the ROC curve for random threshold, and the right side indicates the ROC curve for the distribution based threshold. And looking at these two curves, we can compare the performance itself. We can also see this table, which address other performance matrices such as precision, recall, accuracy, etc.
But sometimes maybe the signals we got the weak signals. Then how it works? It will work or not?
This is our work, ma'am. We have empirically analysis the performance for two different data sets, and we can see that it is working well for both the data sets if we systematically generate the threshold instead of taking some random thresholds.
Okay, good. Okay, fine.
Okay, thank you, ma'am.
Now we can call our next presenter. Mustafa Bohra to present his paper on enhancing surveillance and face recognition with YOLO-based object detection.
Yes, ma'am. Good afternoon, everyone. First of all, I would like to take a moment to express my gratitude for this opportunity to present our project and paper. So let's start with the presentation. Myself, Mustafa Bora, and today's topic for presentation is enhancing surveillance and the face recognition with the YOLO-based technologies, object detection technology. And my co-authors are listed below. These are some contents of our today's presentations. Let's start with the technology introduction. In today's world, we know the object detection technology is rapidly advancing fields that has revolutionized many industries. As the object detection technology comes under the computer vision domain, which enables a system, or we can say the machine, to locate and identify the position of the object in the certain image, or we can say the recorded videos or real-time videos. In our project, we aim to explore the YOLO-based approach to detect object and localize the object. And as we know, as YOLO works well in the real-time detection object, where it uses the single-layer neural network to detect the object. For that, it computational speed get fast and detection speed also get fast. There are many applications of object detection technology in today's world. As we all know, the autonomous driving is the biggest example of object detection, where it uses it used to recognize the traffic signals, paths, traffic signs, and automatically do the work according to that signals, and stops seeing the signals like that. It is used in healthcare to diagnose and check the particular diseases. In robotics, we are using the sensors, different sensor, to detect, or we can say check the obstacle in front of us, using the ultrasonic sensor and different sensor. But by using this object detection technology, we can go in very advanced manner in further. And also the agriculture field, the object detection technology is used to detect the plant diseases and do the particular task according to that. And now going to the objective and the aim of our project, the major problem in while talking about the object detection is locating and as well as the labeling the object in the particular image. So our aim is to differentiate the particular object and find the object in the certain frame of an image, or we can say real-time videos, and for use for surveillance. And this data which are recognized, or we can say detected, should be stored in the particular file for the further evidence or the future use. Next slide. So for our project and the paper, we have researched number of papers. Here are some listed where they have used the different technologies, RNN, CNN. Then they have also used the YOLO. In all papers, they have tried to recognize and identify the object in the different situations. Like in thermal weather, different thermal weathers, they have used this approach, and different type of conditions they have used. So in each paper there gets different accuracies. Like in YOLO they get 70%, some paper get recent paper get 70% accuracy as a result for detections, and the CNN and RN detects gets the accuracy as 83 and 83.5 something. Next slide. So going towards the proposed system and how our complete system works. So basically it takes an input as an image, or we can say real-time video, or real webcam capturing videos. So as it gets that webcam data, it asks for the choice, like what do you want to do? Do you want to go for the object detection or the face recognition systems? So if the particular user goes for the object, press 1, it goes for the object detection in the particular frame, and the object which is detected or can recognize, the bounding boxes are created around that with the confidentiality level, like how much percentage this object may, like a truth object, true positive object. And as a result, it will we will add the speech on that. It will speak out the object name, and if the user inputs the second 2, so it will goes for the face recognition system, where if the data present in the database, if the person's data present in the database previously, then and only then its face is recognized, and as a result it history of recognizing when and time, and with the date and time is stored in the particular Excel sheets. So goes to the methodology part. As YOLO stands for you looks only one. So it has ability to predict all the object in the one forward pass. It doesn't need to repeatedly check the different object for a different time. So it in one pass they can check the complete object number of object in the one picture. So for the YOLO algorithm, they uses a dark net conventional neural network, which is basically a backbone for the YOLO, which is based on RESTnet architecture, which is popularly architected for image classification and detections. And for the object, they can predict the object, detect the object, and create the bounding boxes. Next. So how and what bounding boxes means in YOLO? So basically YOLO works on grading system. It divides the image into the S by S grid and start scanning the object in the particular grid. And if the object matches with the class to the darknet 53 conventional neural network, they will create a bounding box on that particular grid, in one grid. So where there is a 5 parameters in that particular box, bounding boxes X, Y, W, H, and one is a confidentiality, and also one parameter is the class parameter, which object is that. So X and Y stands for the center point of the object, and W and H is for height and the width of the particular bounding box, and confidentiality, how much percentage or how much probability the object is that, and the class, the labeling of the object. So as YOLO works in grid, so it will create the multiple bounding box for the one object. To minimize that bounding box, we have to give the certain threshold conditions to minimize that, and we have to reduce the low confidential score objects, bounding box object, to get the one bounding box, single bounding box object for the particular one object. And there's a one terms called non-max separation, which is used when basically it is used to filter out the multiple bounding box prediction for the same object, keeping only the most likely prediction or the highest confidential score box. Where also NMS removes any redundant box that overlap significance, which others doesn't, remaining only the box which is the highest confidential scores, as I said earlier. Next one. As there is one also terms called intersection over union, because in grid formation it is not necessary that complete object comes into the one grid. So to create a bounding box around the complete image, the intersection over union formula is used, where it will do the division of the intersection and the union of the particular object. Next slide. So goes to the results of our project. Here are some results. We have detected some objects like bottles, paper, persons, backpack, cell phone, etc. With the accuracy of different accuracy for the different object. Like for bottles, it is 88%. For person, approx it is 98%. Backpack 85%. And there are some FPS. If the greater the FPS, result would be greater. It is depend on the processing power and the system architecture and the camera quality. So here are some pictures of the results where object detection is done, and it will create the bounding box near the around the object with labeled person and the confidentiality level. Next. Here is a face recognition result where the person's face which is present in the database is detected, and his time when it detected, and the date is stored in the particular Excel file. Next goes to the future scope. We can increase the accuracy. We would like to increase the accuracy by uploading this huge data and complete system to cloud computing, because it provides better scalability, reliability, and doing the great computational power for the image processing. So we can do that, and would like to create a patent product where we can implement one IoT device where we can use the ESP8266, which is wireless module with the webcam ESP32. It can be installed in the, you can say, in offices also, or you can say in the institution also, where there is both benefit for detecting object and marking the attendance of the particular student or the employees in that companies, or you can say schools. Excellent. So discussion comparing about the previous approaches and what YOLO's work. As YOLO's scan the complete.
Dear presenter, can you please conclude this presentation? You have last 1 minute.
Okay. It uses the single neural network where it scan the complete image in the single go, no repetition is done, as the computational power reduced and energy can be reduced. Next. So the conclusion we have used the 60,000 images for which is divided into the 80 classes, or you can say 80 objects. 80 objects that images are of 60,000 images. Then we have trained that for the object detection, for real-time detection by fine-tuning the training dataset and testing, training the system for the additional iterations and gain the more accuracy and precision. As there is many application of object detection in today's world, where robotics are coming, AIs are coming, this object detection plays a very important role. Yeah, these are the references which are used for our paper and the PPTs. Thank you.
Okay, Mustafa, you have mentioned that you have collect the objects from the images or videos.
Yes.
So suppose how it is accurate to take an object image from the video? How it will be? How it is accurate?
No, I'm not getting the question. For recognition or detection?
Detection.
Ma'am, detection, we have trained the model with the data set of 60,000 images of the particular 80 classes or 80 objects. So the 80 objects can be detected in our system. We have trained according to that.
Okay. And there is many versions of YOLO
Yes, ma'am.
algorithm, and you have choose V3.
Yes, ma'am.
Why you have choose V3? V3 version?
Main point is our system is
Because there is a very advanced versions are available. In last paper, one of your presenters shows
yes.
YOLO version 8.
Yes, ma'am. So the one issue that the computational power and the processing power the system required, we don't have that much of
Okay.
for and we have started beginning, so we have used like how they get getting accurate. So we started with the V3, then we would like to go to the higher version for the accuracy in the further future scopes for creating a particular hardware part.
Okay. Next.
Now we can call our next presenter to present his paper on a mimicry-based network anomaly detection using machine learning and divergence measure.
Yeah, thank you very much. Can I present now?
Yes, start your presentation.
Thank you very much. Yeah. Please let me know if you can see my screen.
Yes, your screen is visible.
Yes.
Thank you very much. So thank you, everyone. Good morning, everyone. My name is Clément Houkevi. I am from Cheikh Anta Diop University in Dakar, in Senegal. So I'm doing this presentation on behalf of my team, composed of Professor Jibiso, Dr. Michel Sek, and myself. So my presentation will be based on KLML, a mimicry-based network anomaly detection system which uses machine learning and the divergence measures. So let's first try to understand what this topic means by answering the question of knowing what network anomaly is. So by network anomaly, we mean patterns that deviate from expected behavior in a network. So every traffic that deviates from the normal behavior, sometimes they can be considered as outliers, exceptions, or peculiarities. So this picture here shows what we mean. On the left side, you can see that there is an expected traffic that is actually the normal traffic. And on the right side, we have the real traffic that we got. And on that real traffic, there are some points that deviate from the normal behavior. And those points are actually called anomalies. So they can be attacks sometimes, and sometimes they may not be attacks. There may be some errors due to the system. So after now that we know what network anomaly is, let's now answer the question why we need to study network anomaly detection systems. First, the first reason is that today there are more sophisticated attackers, and the tools to hack are available everywhere. The second reason is the increasing of the cost of dealing with violation created by cybercrimes. On the picture on the right side, we can see a publication of Accenture in 2009. According to this publication, this cost has increased drastically from 2017 to 2018. The third reason is the limitations of signature-based systems. Actually, signature-based systems are based on the principle that the attacker signatures is known. So signature-based systems do not detect attacks that are not known, that we do not know the signature. So if there's a new attack that has been created, this kind of systems cannot detect those attacks. So that's the reason why we need to study anomaly-based systems, anomaly-based detection systems. So after studying network anomaly, let's see now the divergence measures. And the principal measure that we use actually in our work is Kullback-Leibler measure, divergence. And this divergence actually measures how a probability distribution is different from another. So given P and Q, two probability distribution, two discrete probability distribution, this divergence is given by equation 1, and it actually measures the entropy between P and Q, meaning the quantity of information that P brings and that is not in Q, the difference of information between P and Q. So let's now summarize what our work is about. Actually, we worked on the work proposed by Pukawana and his collaborators in 2015. Actually, they proposed an anomaly detection system that is based on Kullback-Leibler divergence, as we explained before. More specifically, what they do is to compute for each time interval traffics the probability distribution. So for each time interval, they compute the probability distribution, and the objective is to say that for a given time interval, that time interval is suspicious or not. The traffic of that time interval is suspicious or not. So they proposed a model that is described on that picture on the left side. We can't present all of them, but the most important thing is that rule that is called the 3 sigma rule that is here that they used on their model to find a threshold which they use to say if the time interval is suspicious or not. But this rule has some limitations. There are some limitations on the use of this rule, because the rule states on the right side that for a normally distributed data, like data set, or for a normally distributed variable, the 99.7% of the values are between mu minus 3 sigma and mu plus 3 sigma. We mean by mu the mean and sigma the standard deviation. But the problem is that the data that we have, the distributions that we have, from the distribution they used to compute actually the divergences between the distributions that they have defined for each time interval. But these divergences are not normally distributed, and for actually it is possible to do an approximation, but in order to do an approximation, we need a lot of data, and that is not the case always here. So it's important to change this technique that they have used. That is the reason why we proposed a machine learning based technique that replaced that 3 sigma rule, and the main method, the main machine learning algorithm that we used is called K-mean, which is actually used to classify data. So more specifically, we propose this algorithm, which is a kind of a combination between K-means and a dichotomic technique, in order to say whether a time interval is suspicious or not. Here is a visual comparison between what Pukawana and his collaborators has proposed and what we proposed. We also do an evaluation of those two techniques, that the two techniques, the one that we proposed and the one that Pukawana and his collaborators proposed. So for that, we injected 4 types of anomalies in a backbone traffic. We use TCP reply tool in Ubuntu, and we also use some libraries in Python. on 2 data sets. We use the stratosphere data sets, and here are the results that we got. So first, actually, in order to decide whether a time interval I is suspicious or not, in their method and in our method, we use we use some neighbors time interval in order to compute the divergences and in order to decide. So first, we consider 30 neighbors, and here are the results. On the first data set, we can see that our model performs well. And on the second data set, we see that for 3 of them, our model performed than their model. But for the type 3, none of our models and their model perform really well. None. Then we change the number of neighbors to 20, and here are the results. We can see that our models still perform well than their model. In order to compare again, we compute some metrics. Mainly here we compute the recall. Why we compute the recall? We compute the recall because the recall gives what proportion of true anomaly was identified. We did not compute the precision of the F1 score because we're using a streaming data and all true negative values are not known. So for Pukawana and collaborators model, we found 8%, and for our model, we found 59%, which is actually better than the one proposed of Pukawana and his collaborators, but it is still small. 59 is still small, as recall. Other advantages of our model is that it detects anomalies that are not really injected. And that is actually the principle of anomaly detection system. It needs to detect attacks or anomalies that are not known as well. That is a good thing on the first side, but it might also be a false positive. There may be wrong alarms, like there's no attack, there's no anomaly, but it identifies them as an anomaly. And so to sum up, our model, we actually propose in this work an improvement to the model proposed by Pukawana and his collaborator in 2015. The proposed model is efficient than the proposed by Pukawana and his collaborators. And our model also performed well while talking about anomaly reporting time, because when we reduce the number of neighbors, our model still performed than the model of Pukawana's and his collaborators. So the third advantage is that our model also detects some anomaly, some type of anomaly that are not known at the beginning. So for further work, we actually need to still change the decision criteria in order to identify whether a time interval is suspicious or not, in order to improve the efficiency of this system. And we also need to study the best positioning of the tool in a network in order to provide a secure network system. Thank you for your attention.
Okay, your presentation is very good, and your result, you have compared your result with Pukwana's result, right?
Yeah.
And Pukwana's result, you show there it is 833, and your result is 59 approx. So
yeah, Pukawana's is 8%.
8%, and your result is more than
59 is around 59 around. In terms of recall.
Yeah. So on what basis basically this is improved?
I don't understand, please. Sorry.
Your result is improved as compared to Pukwana's result.
Yeah.
So which area you have selected to improve your results, and what tool you have used to improve these results up to that level?
Thank you very much for the question. Actually, I presented on this page, I presented the difficulty on the model. On the left side, you can see the model proposed by Pukawana and his collaborator. On the right side is what we proposed by our team. what has been proposed by our team. On their model, they use a threshold that is not efficient. That is based on a rule that that specified a condition that is not always verified. There's a condition for that rule that is not always verified, and that is the reason why their model is not performing well, and that is the condition that we have changed. So we use we proposed an algorithm instead of using this rule. So our algorithm uses k-means and a dichotomic technique. Thank you.
Okay, thank you.
Yeah.
Now we can call our last presenter. Farah to present her presentation on task allocation in the edge cloud scenario in incorporating priorities, a simulation-based study.
Yeah, hello, am I audible?
Yes.
Yes.
Okay, I'll just share the screen. Good morning, everyone. Myself, Farah Masroor, and I am doing my PhD under Professor Nina Govias and from BITS Pilani, Goa campus. So for today's presentation, my topic is task allocation in the edge cloud scenario, incorporating priority. That is a simulation-based study, and whatever algorithm we have just designed, I'll just explain. So outline of my presentation would be motivation, followed by some of the existing solutions, and then what we have proposed as a solution, and then the results, conclusion, and references. So basically, when we talk about task allocation, we already know there are several algorithms that have come up with. There are several techniques where we know how the task needs to be allocated and how many resources are required, how the resources, with respect to the load balancing, minimizing cost, minimizing time. There are several parameters when we allocate tasks that needs to be considered. So basically, the motivation behind my research work or my allocation towards the task allocation technique was we need a framework for resource allocation that takes into account some unique requirements of each task. So basically, there are technologies, there are algorithms where different kind of techniques are used, but they have not taken some unique requirements of each task, and there is no user preferences. Like we can say in this respect to task, when we talk about the task comes in, we have similar kind of very minute differences between the task, and we give them just the resources which is available, which is takes less time, etc., etc. So but there are some unique requirements of each task, and we also want to optimize the trade-off between the time and the cost. So basically, that I'll explain further what actually the trade-off between time and cost means in my research in this particular paper. Now also the motivation is the framework can be customized to optimize different parameters based on the needs of each organization. So we have somehow designed it's the task allocation problem with respect to each edge and cloud scenario, but this particular algorithm can also be implemented in certain other organizations as well, where similar kind of priority based or incorporating priority between the task where it's required, we can also fit in this particular algorithm to some other organization, in the need of other organization as well. So where there are basically several existing solutions that have been employed in the allocation of virtual machines on cloud and edge solutions. But I want to just make a note about it that, however, it is important to keep in mind that an optimal solution that considered specific parameters for one set of tasks may or may not be suitable or effective for another set of tasks. So it is like what we have done or the others have done. They have taken a certain set of tasks. We think, okay, this is a set of tasks and this will be applicable for all the scenarios, and it will be optimal, it will be best solution for all the scenarios. That is not at all possible. So there is a certain set of tasks which may be very good for a particular organization or particular algorithm, but those tasks may not be fit, and our algorithm may not be fit to other set of tasks which have different parameters or different scenarios. So now another one is the priority queues. So basically, while I was going to the research papers and everywhere, the priority concept was a major highlight of the task allocation, where we can just, the queues were there for the classes of customers on the basis of their priorities. We need to, allocate those particular, you can say, the customers or the, in the same of patients or tasks, all were getting allocated with the respect to the priorities aspect. There are several papers on that particularly. And first, but the modification in the queue was required, where the fine tuning of the customer requirements was very first introduced by Klinrock in 1964 itself. So Klinrock purpose was basically to obtain the required ratios of some of the stationary mean waiting times, so that the customer's experience should be very good. So basically, we all have also done the experimental analysis on several ratios with respect to tasks, several ratio sets with respect to resources, like how many particular resources are required for a particular set of tasks, and what should be the you can say the ratio set of the resources, what should be the ratio set of the tasks, which all are applicable, how many resources are required for this many set of tasks. These all things have been considered in this paper. So these are several challenges where we face the resource, like how to prioritize tasks, we should ensure fairness, we should reduce the waiting time, minimize cost, all those particular challenges that we face. Now, in my model, the parameters that I have considered are the time length requirements of each task. So basically, there is a time length requirement. Each task has some specific time that needs to be covered, like a particular task requires this many units of time to get the, to complete that particular task. Also, there is a degree of priority of tasks. Basically, I have divided, like we have divided the tasks into two categories. One is the high priority task and another one is the low priority task on the basis of subscription models. Now, the next one is what parameter is number of unallocated tasks. So basically, we have also seen how many tasks are unallocated. Now, the ideal time of the servers, the waiting time of the tasks. Now, in my proposed work, I have done the resource allocation problem is there. Now, what we have done is we wanted to optimize the trade-off between time and cost concept is coming up. So we wanted to optimize cost as well as time. So whenever a task arrives, they have an opportunity on the basis of subscription model, whether they want to optimize cost or they want to optimize time. If they want to optimize cost, then they have to pay less because they want their cost to be minimal. So they will have to pay less and they will be in a low priority queue. So this is the main concept, like when they want to optimize cost, they will be in a low priority queue. But when they want to optimize time, that means they want their waiting time to get reduced. Now the tasks are coming, they want their waiting time to get it reduced, so they will pay more and they will be in a high priority queue. So basically, here comes the classification of the task in the basis of low and the high priority. Now what happens is, whenever now we have done the discrimination of the high and the low priority. Now what happens is, since they have paid the high priority tasks have paid more and they want their waiting time to get reduced, now here in the resources part, we have two categories of resources like servers available. One is the edge server and another one is the cloud server. So we have rented, we wanted to like with the concept of virtual machines. So there are several virtual machines on both the edge and the cloud servers. In my particular, you can see the results, there is 2,500 tasks we have taken. And with those 2,500 tasks, there are 100 resources, like 100 virtual machines available. Now, those virtual machines are divided on the edge and the cloud servers. Now, in our algorithm, what we did is we have given an opportunity where the high priority tasks can only be executed and can only get the cloud server virtual machines. Once the cloud server virtual machines are not available, because see, they are high priority tasks, so we need their waiting time to get reduced. So for that to happen, we have given a technique where the high priority task can only be, firstly, they will go to the cloud server virtual machines. They'll check whether the virtual machines are available or not. If the cloud server virtual machines are available, then that high priority task one by one will get. One more thing, the arrival of those tasks is on the basis of Poisson distribution. So all the tasks are independent of each other. They are not like at a stretch, all the 10 tasks will be coming up, or every task is coming at different interval of time. So basically, whenever the tasks are coming up, according to the subscription, high and low priority, they are getting divided. Now, if the high priority tasks, they will be going to the cloud servers. And if suppose cloud server virtual machines are not available, then they will be seeing and checking the edge server virtual machines. If edge server virtual machines are available, then they will be getting allocated. Now, with respect to the low priority task, they only have the preference to be getting allocated with the edge server virtual machines. They cannot get the cloud server. Because why we have done this discrimination? Because they are low priority tasks. We wanted the high priority task to firstly to get preferences, second to reduce their waiting time, since they're paying more. So in that case, we have done the discrimination. Now the question arises, if we are doing this way, then there will be a starvation for the low priority tasks, right? Because they are one by one, all the high priority tasks are getting executed and the low priority tasks are getting starved. They will be waiting in a queue. So of course, they will have a very high waiting time, which we didn't wanted. We want that, in fact, okay, they are in a low priority task, but they should also get the some kind of preferences. So to balance that out, we have tested with several ratios. There comes the ratio factor of k:1. So k is basically the high priority task and 1 are the low priority tasks. So with that, firstly, what we did is in the very initial stages, we have experimented with several ratio sets, like it was 2:1, 2:4, 2:6, 2:8, then similarly increase, decrease, all these things. Now, what is that 2:1, 3:1? I'll explain that. Now, that is maintain a priority queue of 2:1. That means, firstly, 2 of the high priority tasks will get executed from the queue, and then the 1 of the low priority task will be getting executed. So similarly, 3:1. That means 3 high priority and then 1 low priority. Then 4 high priority and then 1 low priority. So this way, what happened is we have found out that the best ratio set for the task, like you can see in the result, it is k:1 task ratio. That means 2:1, 3:1, 4:1, 5:1. With all the ratio sets, we found out that 2:1 is the best task ratio set, which fits with all the parameters like waiting time of low priority. We can say high priority ratio set also it's good. Number of unallocated task is also good in this 2:1 set. Right. So this way we found out that 2:1 is the best ratio set with respect to the task aspect. Now comes how many resources are required. So firstly, what we did is 100 resources were there. We did the 50-50 of that, like 15 the edge, 15 the cloud server. You can see here in this 50-50, then we have increased like m.m, we can say it was m.n, so m plus 5, n minus 5. N plus 10, M minus 10. This way, this is actually with not only with this, we have experimented with several cases, but these were the most feasible ones. So we have just put results in this aspect. So basically, with this, we found out that 80:20 is the best resource set, which is applicable for 2,500 tasks to get executed. You can see here as well. These are the parameters for selecting the virtual machines on the edge and cloud scenario. See, in maximum cases, it's 80:20 that fits in as a best case. Right. So basically, we found out that 80 machines, you can see here, I'll just explain here, 80 machines on the edge server and 20 machines on the cloud server can effectively handle 2,500 tasks. Now the point was, since we had several unallocated tasks left, we wanted to figure out how those unallocated tasks can get the allocation. So with that, what we did is, here is, you can see there is a comparison of parameters on adding 10 virtual machines, each on the servers at the beginning and at the transition point T60. What is the transition point means? Transition point means, as you can see in this Gantt chart, after 60, there were very few machines, tasks that was getting allocated. So we wanted that transition point where after that only few tasks are getting allocated. So it was 60, and then what we did is at 60, we have added 10 virtual machines on both ends. Now 100 say 120, you can say virtual machines was there. But that 120 was previously, it was 80-20 ratio that was best suited, right? So there what we did is 80 say we have increased to 10, that is 90, and 20 we have increased to 10, that is 30. Now 90-30 ratio of the resources were the best, you can say the edge in the cloud server, like 90 in the edge and 30 in the cloud. Now the problem was that 10 resources should be added where? Whether it should be added in the beginning of the a task allocation process, or it should be added at 60 at the transition point. We wanted to check that. Now we did both the things. We have added at 60 and we have added at the beginning. Then we found out that from the beginning, if we add 10, because ultimately the cost would be coming for the resources same, whether we hire them at 60 or hire them at the beginning, right? So we wanted to check whether with that, these were the parameters that you could see, like unallocated task, high priority, low priority, then average waiting time, ideal time of the high priority and low priority, maximum only this, because see, the waiting time is inversely proportional to the ideal time. Now the aspect comes according to
Dear
the
presenter, can you please conclude your presentation?
Yeah, I'll just conclude. It's the last slide. Yeah. So basically,
time is inversely proportional to the low priority tasks. Hello, am I audible?
Yes, you're audible.
Hello.
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 Yes,
Yes,
yes. Yeah.
you're
So
audible.
basically, yeah, sorry. So that high priority that is inversely proportional. So now the organization has this, freedom, whether they want their idle time for the resources more, or like they wanted, okay, no, we want the less idle time, so they can just add at 60, because we can see that at 60 the idle time is coming low. But if they want the waiting time, like they have the preference for the task, so they should be adding those resources from the beginning. So this is the conclusion of our work, where we found out that the optimal solution was found out to be maximum time for is to be 2 for low priority tasks. Actually, what happened, I didn't explain that. The point is that whenever the low priority tasks had the time limit of maximum of 2, like they can in the very beginning I've told there is time requirements, so they can have only 1 unit or maximum of 2 units, whereas high priority tasks in the all of the cases they can have up to 10 units, because they are high priority, so they are given high preferences, so they can take the time requirement up to 10 units. And then the task ratio of high priority over low priority was 2:1, that I already explained. We have done the analysis with several aspects. Now the model recommends using 80 virtual machines on the edge and 20 virtual machines on the cloud, also to handle 2500 tasks, but still there were several unallocated tasks left. So introducing extra VMs at the beginning of the task sequence is found to be more efficient reduction of unallocated tasks than adding at the transition point. And adding 10 extra virtual machines on both the servers lead to the more feasible allocation process. Now this is the conclusion, and our future work is basically we are working on something related to the agents part. We are just moving towards the agent and towards the geographical locations, like we want like there should be several tasks from several resources, and all of this work is done in Python for now. And we have also used Mesa, that is an agent based approach in Python, to just simulate all these things. Now even right now I'm working on this this version has been put on in the cloud sim as well, because this was done in the Python. So we have just experimented everything and we have put the same in the cloud simulator, because that is a very good simulator nowadays for just evaluating whether the everything results are coming accurate or not. So hopefully in the future work will be presenting that as well, how the whole work into the cloud sim, as well as some geographical aspects where the different tasks will be coming on from different locations, and then we'll see which task should be moving to which of the virtual machines on edge and which of the virtual machines on the cloud. So that's all for today. These are the references. I've put in some, and thank you. Any questions, ma'am?
Yeah, just one question.
Yeah,
you have mentioned that all the tasks are independent.
Yes, ma'am.
And then just tell me what about the low priority task? Then it will generate the starvation problem.
No, that's what, ma'am. For that reason, we have done is the ratio set. We have varied with several ratio sets where 2:1. Like we have not put all the low priority task into starvation. We are doing is first the 2 high priority tasks will get executed, and then we'll pick one from the low priority task. There are 2 queues, right? One is the high priority queue and the other one is the low priority queue. So what happens is, according to the first come first serve basis, they are just coming and getting fixed on that particular queue. So the 2 high priority tasks will get executed, and then the one from the low priority. Yeah.
Okay.
So, ma'am, we have
Alternate.
tested with several cases, like 2:1, 4:1, 5. Many cases we did, and we found out that no, this 2:1 is the best case. First, we should give 2 high priority, and then we should give 1. So this way, ma'am, you can see the results also. The low priority tasks are not getting so much of starvation. Like they are also giving. That is what our main point click. See, if we will be giving all the preferences to the high priority, then what will happen to the low priority? They have to wait for long. We didn't wanted that to happen.
Okay.
Yeah.
Okay. Yeah.
Done. We had completed all the presentation. I sincerely thank our authors for the excellent presentation and contribution in this session, and all our participants for being a part of this international conference. Thank you so much, everyone. I hope this session was informative enough. We, on the behalf of the whole team, thank you for the support during this 7th version and the previous 6 versions of the conference. We will be happy to have you in the 8th version of ICTIS in 2024. All the presenters would be getting digital certificates through email within 2 working days. Further, all the papers have already forwarded to the Springer. The publication will be live within 5 to 6 months. So kindly be cooperate with the team of ICTIS. And now I also thank our chair of this session, Dr. Vijita, ma'am.
Thank you, ma'am. Thank you so much.
Ma'am, this is a token of appreciation on the behalf of Team Global Knowledge Research Foundation and ICTIS.
Thank you, ma'am. Thank you so much for your always support and.
Thank you so much, ma'am. And I have one more request to everyone. Please turn on the camera for taking a quick snapshot for making this virtual conference more memorable. Thank you so much, everyone. Thank you so much, ma'am.
Thank you.
Thank you.